All right, so yesterday we finished with a reference angle. I don't know if you understand reference angle, but I'll give you another example. A reference angle is, let's just say, give you an example. Yesterday we give you something that's kind of difficult, and I'll explain again. 10 pi over 7. The reference angle is gonna be 3 pi over 7, and the reason being is always use the x-axis to figure out what is a reference reference angle. So this one is gonna be 0 and this one's gonna be pi, but pi can also equal to 7 pi over 7. Does that make sense? So that makes 14 pi over 7 over here. So that makes 10.5 pi over 7 here. So we know 10.5 pi is at the y-axis. So 10 pi over 7 is less than that, so it must be third quadrant. It has to be third quadrant here. So this one is 10 pi over 7. So the difference over here is going to be 3 pi over 7. And that's the reference angle. Does that make sense? Because we say form with the closest x-axis. It's forming with the closest x-axis. So let me give you a question. Let's say if today is 9 pi over 17, what will be a reference angle of 9 pi over 17? Oh, sorry, not 9 pi over 17 pi over 9. What will be reference angle of 17 pi over 9?
Fourth quadrant.
No, wait.
Yeah. If that's 18 pi over 9 and 17 pi over 9.
If it was 9 feet high, it would be like pi
From 18 to get oh yeah, no, he's right. Which means you're right. The reference angle can only be, I was thinking kind of, that's the one.
All right, so the reference angle here is pi over 9. The reason being is that 18 pi over 9 is on x-axis, the closest to, so you want to figure out what the quadrant is, right? So if I go in here, it's 9 pi over 9, and when I go here, it's 18 pi over 9, but it's not yet there. So this is the angle opening. This is the reference angle here, so it's pi over 9. So reference angle in this case is pi over 9. Does this make sense?
Can we have another one?
Yes.
You need some more practice.
Reference angle and coterminal angle are slightly different. Coterminal angle is same representation. Reference angle is only between 0 to 90 degrees or 0 to pi over 2 and it's positive. So it's, if this is 17 pi over 9, the closest to x-axis is right here, right? Which is, it's only 1 pi over 9 away from 18 pi over 9. So therefore it's pi over 9.
Okay.
Does that make sense or no? No? It doesn't make sense?
That's true, yeah.
Okay, so
Can you mix them?
Yeah.
Properties?
So what is it?
okay, let me ask a question. Okay, how many of you guys don't understand besides Devin? Jasmine? Okay, okay, Brandon, look. Okay, that's fine. So that just say reference angle. So think about a reference angle. The definition of reference angle is going to be between 0 to 90 degree. It's from with the terminal side to the closest x-axis. So from here to here is the closest x-axis, not on the other side, right? So the closest axis is this side. This side is the other x-axis on the other side, but that's not the closest. To closest is to the x-axis here. So obviously, if it's 17 pi over 9, it's all the way in fourth quadrant. So let's just say if you go around the track, it takes 18 minutes, right? At 17 minutes, how far are you away from the final finish line? You still have 1 minute left, right? So basically, this is what pi over 9 is. That 1 minute left to get there. Yes, Brandon. You can but you gotta understand reference angle has to be positive. So you have to subtract the bigger one with the small one. You can subtract small one with bigger one, but you can do absolute value of that. So you can do 17 pi minus 18 pi over 9 and then have absolute value of that to get the distance. Because right here, we just want to try to get distance from here to here, and that's the ideal reference angle. Okay, yes.
How do you determine which side to go to if it's, for example, like 13 pi or 13.5 pi over 9?
Okay, so that's 13.5 pi over 9. It has 90 degree of the reference angle is going to be 90 degrees, or pi over 2, because you pick exactly a very, very awkward on a y-axis situation. So it can go either way. So it's going to be 90 degree either way. So let's just say today I have reference angle. For let's say I'll give you a weird one. Let's say 8 pi over 19. Right? 8 pi over 19. Oh, sorry, let's not do that 8 pi over 19. Let's do 14 pi over 19. So which quadrant would it belong to? You gotta ask that question. No, it's not. Yes, it's correct. Okay. What's the reference angle of 14 pi over 19? So look what you get.
I said that it was 5 pi.
Okay, Devin.
5 pi over 19.
5 pi over 19 is correct. The reason why it's 5 pi over 19 is right here is 19 pi over 19, right? Does that make sense? So 14 pi over, so it's over, let's say half of a 19 is at 9.5. It's over 9.5, so it's on this quadrant, right? So you can say this is a 14 pi over 19. But we are just asking this angle right here. Is how far away 14 pi over 19 to 19 pi over 19. So this has to be 5 pi over 19. So that is going to be the reference angle. Okay? Is this okay? Yes. No, the reference angle is only positive. All right. So let's help you something with SAT, which is has something to do with SOHCAHTOA, and you have to understand SOHCAHTOA. So the question is gonna be like this. We're gonna go into understand all the detailed right triangle and situations. So a lot of you guys are already pretty good at this type of stuff, but I want you to get even if it's on SAT, you know what to do with it. So let's just say if today we're gonna talk about we already know SOHCAHTOA, right? So ka toa. So that turns out that there is this sine theta is equal to opposite over hypotenuse, and the cosine theta is equal to adjacent over hypotenuse. We already know that tangent theta is equal to opposite over adjacent. But what is the cosecant theta? In terms of for the side, like hypotenuse over opposite. Good job. And in terms of secant theta, is gonna be what? Good. And so cotangent theta is equal to what? Adjacent over hypotenuse, right? Oh, sorry. No, adjacent over opposite. Thank you. So this one sounds like Chinese name. Chiu Sha Kao. Actually, this could be Chinese name. Chiu Sha Kao. Right? So it's the opposite of it.
Chinese ping pong player.
Chiu Sha Kao. Okay, is this okay? Okay, so now we know that because we have implemented both way, so we can see all the things works. So we can say, okay, well, if today I have sine of theta is equal to 2 over 5, and the cosine of theta is equal to square root of 21 over 5. Can you find cosecant of theta? Can you find secant of theta? And can you find cotangent of theta?
This is root what?
Root 21 over 5. Okay, let me ask. Kennedy, what'd you get for cosecant theta? 5 over 2 is good because it's opposite of sine theta, right? So this is a 5 over 2. What is secant of theta? Yup.
Actually didn't do that.
But if you were to wing it right here, what would you get?
Oh, it's 5.
Okay, 5 over 21. Good. You have to rationalize it though. So 5 root 21 over 21. It's fine. Nick, can you tell me what's cotangent of theta here?
Honestly, didn't get there yet. Let me try doing it right now.
Yeah.
No, it's not. No.
Yeah, so what would it be?
I got root 21 over 2, but I don't know if you could. I don't know if that's right. I don't think it's right.
Root 21 over 2 is right.
Oh.
So cotangent theta is equal to cosine theta over sine theta, right? Because I can use the identity, right? So cosine theta is going to be square root 21 over 5 over 2 over 5, right? So it'd be square root 21 over 5 times 5 over 2. So cancel out square root 21 over 2. Is that okay? Pretty easy, right? Questions? It's okay, right? So if you use your iPhone calculator, now I'm going to show you Desmos calculator and iPhone calculator. There's a small difference. So I just show you that iPhone calculator first. Let's say, I don't know if it, oh, iPad doesn't have a calculator. Oh, they do. Okay, good.
Oh my.
So notice there was two things you have to know. I'm just showing you iPhone calculator first. I'm gonna show you Desmos in a second. You're gonna using Desmos, but I won't show you iPhone because a lot of time you use an iPhone calculator and you need to know what to do with it. So for example, that we know sine of 30 degree is what? Sine of 30 degree is pi over 6, but then you no, sine of 30 degree is not pi over 6.
Square or root 3 over 2.
It's 1/2.
Oh.
So look at here. It on the right hand corner here, it has a radian, right? It has a rad over there. That means radian. So you need to change to degree before you get 1/2. You get 0.5. But if I do it in rad, what will happen? Well, if I do sine of 30 degrees, sorry, sine of 30 degree, it's gonna give you negative 9.88 because they're using 30 radian rather than 30 degrees. So you gotta understand that you can change a degree and radian setting here by changing this. Does that make sense? So then you can also recognize at this calculator, at this particular calculator, it does not have a cosecant button. Does not have a secant button. So what do we do with this type of calculator? Now Desmos can. So if I say, hey, I want to find out cosecant of 30 degree is, how do I use a calculator? By the way, you should know what's cosecant of 30 degree.
You have to apply the other identities.
Yeah, which identity?
So for doing cosecant, we're doing secant, then it would just be 1 over cosecant.
Yeah, but we're asking cosecant. Let's say cosecant of 30 degree. How would I use a calculator
Oh, wait, see this.
to get the same value?
You put 1 over section. You put 1 and then you divide it by 10.
Yeah, 1 divided by, not cosine, sine, right? Sine of 30 degrees. And then you say, oh, okay, well, wait, that's radian. So I'm going to change that to degree. So 1 over sine of 30. Guys, I cannot talk over you guys. If you have a conversation, fine. Then you can talk and I'll shut up. But let me talk. Because if I have a question, then I'll answer it all of them at the same time. So this becomes true. So this is correct. Okay? So therefore, you got to understand that you have to use a calculator. Now on Desmos, it's a little bit different. On Desmos, it's going to be here. The way you get the degree is going to go into here. And there is a radian and degree. Did you see that? So you got to click a wrench. Do you guys know this? In geometry, do they teach you? No, but so now you know. If I want to change the setting, that is going to be degree or radian, I'm going to type in here, right? I'm going to go to here. So if for today I want a degree, I can make sure the radian change to degree. So knowing how to use decimal. So we know that if we can type in sine of 30 degrees, this is 30 degrees. But if you click on the radian, you'll pop out negative 9.88. But if we wanted sine of 30 degree, that's how we're gonna get. We had to make sure this is in degree mode to convert it back. So that way your calculation, when you're using calculator on AP exam, you're not gonna use the wrong thing. Because most of the settings gonna start with radian. All the settings gonna start with radian. You're gonna change your degrees. Now, luckily, if you type in, if you look at here, right? Wait, how do I get the keyboard? Okay, there's keyboard. So there is it's all 6 trig functions here. So you don't have that issue says, hey, I need to use 1 over sine for cosecant. I can just use sine here. I can use, there's a cosecant button. So if you see here, if I type in cosecant 30, right? That's equal to 2. But 1 over sine of 30 is also 1 over sine 30 is also 2. So you gotta make sure that degree and radian, you gotta be able to switch. Otherwise, you're gonna get completely different answer. So please make sure you understand that. With that understanding, you can move on to different ideas. So what if I ask you radian? Well, if today I ask you radian, let's say sine of pi over 6, right? Let's say sine of pi over 6. Wait, hold on a second. We know sine of pi over 6 is what? What is sine of pi over 6? 1/2, right? But how come the value is not coming at 1/2? Because this one is in radian, so you make sure it's in radian. Devin, are you paying attention? Make sure the thing's in radian. Sine of pi over 6, make sure in radian. Because if you click degree, you'll go back to before. So now you want a radian because your input is radian. So you gotta make sure you understand what your input is. Your input is radian, then you have to change the calculator setting in radian. If my input is in degree, I need to change my input into degree. So that help you with the physics class. If you take in physics later, that I know Greenwald's not going to teach you, so I'm going to teach you now. Sorry, that's like kind of easy to throw in the shade. So even simple stuff like this, you got to make sure you don't mess up, because if you type in the wrong degree, then type in a degree inside radian, it's the wrong thing. So you got to make sure you understand that. Okay, so now you know that. I'm going to talk about one thing, a few things that's on SAT you have to worry about. So if today I have a triangle, and this triangle is going to be 5 and 12, and this is a right triangle. I want to say, hey, can you find sine of theta, cosine of theta, tangent of theta? Can you find cosecant of theta, secant of theta, and the cotangent of theta? Can you find all the thing here if the data is right here? I'm glad Elizabeth pointed out we don't have hypotenuse. What do we do if we don't have hypotenuse? Okay, so with Pythagorean you can figure out. So you should be able to figure out all 6 trig functions. Huh? No. What are you thinking? You're thinking about, oh, you think about 45, 45, 90. No, this is not 45, 45, 90. This is actually Pythagorean triplets. David, you done?
Maybe. Might be like really stupid.
What the?
Yeah, improper fraction is fine. Improper fraction is simplified. Makes numbers stupid.
Gotcha.
Okay, so then you can say, hey, I can use a Pythagorean identity to figure out the third side. But end up this is a Pythagorean triplets. How many different Pythagorean triplets are there that you know of? Pythagorean triplet. Do you guys know what Pythagorean triplet is? Pythagorean triplets.
Like the common one?
Yeah.
4, 5, 6.
4, 5, 6 is not one of them.
3, 4, 5.
3, 4, 5. Thank you. Or any multiple of 3, 4, 5. 6, 8, 10. 9, 12, 15. Those are the common ones, the 3, 4, 5. On SAT, stick with 3, 4, 5. Usually it's always 3, 4, 5. There's more rare one, will be 5, 12, 13. 7, 8, 9 is not one of them.
I know.
Okay, so 5, 12, 13 is another type of triplet. There's one more. It happened very, very few times. But that does happen. Is 7, 24, 25. This is the common one, I would say. There was some uncommon one that I don't remember. I remember this 3, but there was plenty. There was infinite amount actually of Pythagorean triplet. So this is the only one that I use commonly all the time. Now, this side is always hypotenuse. This side is always hypotenuse. Always hypotenuse. The longer side is always hypotenuse. So then you can figure out by using Pythagorean identity, a squared plus b squared equal to c squared. So that's going to be 5, 12. 5 squared plus 12 squared equal to c squared. C squared is equal to 169. C is equal to 13. So therefore, once we got this 13, guess what? It's going to be 12 over 13 and 13 over 12, right? And 5 over 13 and what? 13 over 5. And the tangent is going to be 12 over 5, 5 over 12. And you think like this knowledge only use that here. You're wrong. Today I'm teaching BC Calc. Guess what? Let's scroll back a little bit. Just a little bit right here. Look at here. At the end, I got sine theta, right? I got sine theta at the end. It's sine theta cubed over 12. And the answer is this. And you look like, wait, how do I get that? Because beginning of the problem, we had to draw a right triangle out. And sine is the opposite. Square root of x squared minus 4. The hypotenuse is x. And this is a BC Calc because you have to, at the end, you had to put in, you cannot just leave your answer as sine theta. You had to convert it back to using triangle. And guess what? We're doing the same thing. So right now, if we build a right foundation, you go to BC Calc, you're going to be like, oh, okay, this is something I know how to do. Okay? So it is a knowledge you have to retain from now on and just have to keep on retaining all the way through. Even the Pythagorean identity I show you is easy. It's going to be like that. Okay, so I'm going to show you, we already know Pythagorean identity. What is Pythagorean identity? Sine square plus cosine square is equal to 1, right? Hey, if sine of theta is equal to 3 over 5, can you find what's cosine of theta? There's a few ways to do it though. I'll show you 2 different ways to approach it. One is easier than the other way. David, you already got it? I see you drop your pencil.
Well, you're right.
Luke, you got it?
That was a sign of privilege.
I'm desperation.
One way is gonna be harder way. One way is super easy. So if sine of theta is equal to 3/5, what is cosine theta? What? No. David?
I put
2/5 is not right.
it's 4/5.
It is 4/5. Good job, Kennedy.
How we get that?
Okay, so
Thank you.
I got it.
with this, right? I'm gonna show you the shorter way. I'm gonna show you the longer way. With this, I can draw a right triangle. I can draw this theta, right? So this is 3 and this is 5, right? So guess what? This is 3, 4, 5 triangle, right? And the cosine theta is gonna be 4/5. Now I'm gonna show you a harder way. Look at this, right? If a sine theta plus cosine squared theta is equal to 1. Now this is a harder way. I just do 3/5 squared? Can I replace sine theta with 3/5? Plus cosine squared theta is equal to 1.
Yeah, that's the way that I was about to do.
And then that's gonna be 9/25, right? Plus cosine squared theta equal to 1, right? Cosine squared theta is equal to 1 minus 9/25, which is what? 16/25. But that's cosine squared theta, right? What is cosine theta? Square root of 16/25, 4/5. Much longer way to do it,
Yeah.
but you get the same answer. And then, Sayo, your job is to wake her up, smack her in the head every time she falls asleep. Go like this.
Mr. A, who's nice handwriting?
Gabby Steffler. Okay, does that make sense?
Who's that?
Does this make sense?
Yes.
Okay. How much time I have?
15 minutes.
15 minutes. I have a lot of time. Okay.
14?
All right. So I'm gonna tell you about on SAT. They often ask this type of question. They often ask this type of question. But I'm gonna start with something that is more doable. I'm gonna start with wait, which question I want to do? I don't see it. I don't see it. I don't see it. Okay. So I'm gonna start with the easier question. So this is the one the question on homework. If this is a 10, this is 26, and the data. So what will be the cosine of theta here? Look.
Oh, wait, is it 25 over 26? That's just a guess. 12 over
Oh, are we supposed to, like,
13?
You're not supposed to guess. You're supposed to figure out.
no, is there like a formula, like, you know how like you have the triplet thingies? Is it one of those, or like, can we actually?
Divide that by 20.
Possibly.
Divide those numbers by 20.
Oh my.
This one you don't need a calculator. Yes. What'd you say? 24 is the final answer? No, I'm asking cosine theta. I'm not asking the third side.
Triangles now have this.
Brandon? 12 over 13 is correct. Okay, so remember, I can use this way 10 squared plus, well, we don't know this side, right? X squared equal to 26 squared. And some people ask me to use calculator. It turns out you don't need to use calculator, but it's okay. X squared equal to 26 squared minus 10 squared. I have no idea what's 26 squared. Does anybody know?
676.
What?
676. I'm not playing with you.
576.
676.
Anybody laughing at that?
It's 7? 67?
No, the other way.
576.
676.
Minus 100 is equal to 576. X is equal to 24, right? So it turns out I don't need to do all that work because this is a 5, 12, 13 triangle.
Oh, are we serious?
Yeah, because this is 5, this is 12, this is 13, right? So therefore this is double, this must be doubled as well. So it's 24, and this double is 26, right? So therefore that we know is 24 over 26, 24 over 26. So it's 12 over 13. So the answer is 12 over 13. Now, sometimes you need to use Pythagorean identity? Yes, absolutely. On your SAT, you're gonna have to use Pythagorean identity a lot of time. Now, a lot of time you also need to use, faster way. You don't have time to plug in the calculator. You can see if there's Pythagorean triplets. Triplet is very easy to see. For me, this one is very obvious because 5 and 13 is up there. It's just missing a 12. Yes.
How common is it that you come across?
In my test, 50-50. In the SAT is about 70-30.
Really? So
Yeah.
70% of the time.
Yeah, you will have a triplet. Unless they specifically ask you Pythagorean identity, which is Pythagorean identity is pretty often. Also, they like that identity, so they will ask that. Now,
Doing more and more like geometry so that you can't like only use the calculator.
Yeah. There's a lot of trig and geometry on the last one that you can't like just cheat with that.
For real.
Yeah.
no, that's good. I like that. Yes,
You take that SAT, you took the math.
I take it before.
Wait, what do you have?
My own SAT when I took it, my own SAT I got 720, but that's back in the day. Now it's a watered down SAT. So back in the day when I was taking it, the question's actually hard. That's a first condition. Second condition is they actually have 5 choices instead of 4, and they have fill in the blank. And then if you guess it wrong, they take a quarter points out each row. So instead of you get an answer, you get actually a quarter points off. Okay, so you cannot guess on a question you don't know how to do. Huh?
If you left it.
Yeah, you left it blank. If you completely don't know, you left it blank. If you guess, you're gonna get penalized for guessing.
Yeah.
Okay.
And then half of the test with the calculator is not graphing calculator, it's scientific calculator.
Yeah.
So that was when I was taking it, but that was really hard.
It is kind of crazy that we get to use those notes. I feel like that's kind of cool.
It's actually cheat. It's actually just.
It's awesome.
Huh?
You just get an answer in the SAT now?
No, like when people ask me would I get 800 on SAT math, no. It really depends on that question if I can figure out really quickly or really slowly. So if I figure out slowly and if I make some simple mistake, I will get 790 half the time and 800 half the time. So I will make mistakes too. I'm like you. I'm just as bad as anybody here make mistakes. So I will make that mistake sometimes, especially on the last question. All right, so one of the things on SAT is this identity. A lot of people don't recognize it, guys. I'm going to talk about. It's called co-function identity.
Is this SAT or still not SAT?
If you know this, it will help you on SAT. It's called cofunction identity. Sine of theta is equal to cosine of 90 minus theta. Cosine theta is equal to sine of 90 minus theta. And the tangent theta is equal to cotangent of 90 minus theta. And you're gonna be like, why is this important? I will show you why this is important, because sometimes you can figure out, you're gonna see those type of SAT question on the blue book. It's actually on the blue book have a lot of those questions already. And you got a cotangent of theta is equal to cotangent equal to tangent of 90 minus theta, and secant of theta is equal to cosecant of 90 minus theta, and cosecant of theta is equal to secant of 90 minus theta. Now, all those 90-degree can be replaced as 502, because sometimes it could be radians. Okay? Now, for the things that you need to know more often, it's going to be this 3. That's more likely to be on SAT. I'm going to tell you where it is. It's actually not... I will show you some SAT question tomorrow about those kind of things that you're gonna see. But today I'm gonna say this is it is. Now, how do I know that? We already know that, believe it or not. You think about it. What is sine of 30 degrees is? No, look at it. Look at it's 1/2, right? So it's equal to what? Cosine of 90 minus 30. Sine of 30 is equal to cosine of 60, right? You look at unit circle, they both equal to 1/2. So you are using it all the time. You just don't know that this is what I call. Because you see that sine of 30 degree is equal to cosine of 90 minus 30. You look at cosine of 60 degree is 1/2. Sine of 30 degree is also 1/2. You know they are the same answer. Now I will show you what a question will look like on the college board look like. But also another way to prove it, guys, another way to prove it is theta 90 minus theta. And if you have C, B, A, right? If you look at this, sine of theta is equal to what? A over C, right? Now, what if I treat this as a theta? So what is cosine of 90 minus theta? It's also equal to A over C, right? So therefore, sine of theta is equal to cosine of 90 minus theta. So we just show you the proof why that is, because we can treat this as theta and we can call it as 90 minus theta, as A over C. Same thing, sine of theta is also A over C. So you can say those two are equal to each other. A very simple proof to show you that these two are equal to each other. We will show you what the SAT question look like tomorrow. Now, I want you to actually start looking at the SAT question as much as you can. The next SAT is going to be March. A lot of you guys senior, you're going to depend on that score. Some juniors need to depend on that score. Some sophomore need to depend on that score.
You can apply for college after March.
Now, for me, I will tell you, if you have any friends, you should tell them, get it done at freshman year. If you're smart, get it done at freshman year. Because if you take a pre-calculus, like Chase, right now, Gia, Shreya, Chase, Devin, you should take one this year to test the water. I already asked Devin to take it because I'm not paying for his damn college. I can afford it. He better get his own damn scholarship. I just want him to get it. Bright future, he can go anywhere in Florida. So I don't want you to stress out like, I don't know, some of you senior, Yop and Nicholas right now is stressing out. I'm not.
I got it. I'm at 75% on the last SAT that I took.
Okay, good. Congratulations. But I want you to try for 100% because that's still 25%. So get it in right now. So Shreya, Chase, and Gia, I will take it once this year. I will register for June after AP exam. I know y'all stress out. Try to prepare as hard as you can. Try to get your first step. So weather hole, we can teach 2 more hours.
Interest meeting will be after school in room 400.
In room 4. Last question.
Sure.
Do you have it?
Oh, that one? That one's hard. That one will not be.
But do you have the answer?
Yes.
I think I messed up somewhere, but I don't know where I messed up.
Right there, that's my handwriting. I don't know if you can decipher it.
Oh, that makes sense. I didn't. These should have been flipped around.
Sonali, you doing okay? You understand?
Can you redo it? Because I messed up here. I flipped them around. I'll redo it when I get home. Thank you, Mr. Yashi. Did you have you graded the test from? Oh wait.
Tomorrow we'll grade it again.
Okay.
Let me guess, this is author. Let me guess, that's probably author. Guess who is it?
Tell him to go away.